Okay, hello friends, we are live. Today we are going to debate between Alexey Burov and James Fodor, and this will be a formal debate. 20 minutes for opening statement for each speaker, and then we are going to response to each speaker, and then we are going to cross-examination and Q&A from our listeners. Okay. Alexey, can you please tell us about yourself a little bit?
About myself, I was born and raised in Novosibirsk, Soviet Union at that time, Russia now, and then I got my PhD in Novosibirsk University in physics, mathematical physics, and then worked quite a bit in Budker Institute of Nuclear Physics in Novosibirsk, and then since 1997 I have been working at Fermi National Laboratory, United States, which is close to Chicago. And I am fellow of American Physical Society, senior scientist of the laboratory, and in my spare time, I'm a philosophical blogger. I'm writing essays, mostly in Russian, in my blog, snob.ru, Russian blog, but time to time I'm writing English essays. Some essays are written by myself, but all my English essays are written together with my son, Lev, and I will tell about them a little bit during my talk. So I think mostly, also I am a leader and the organizer of Fermi Society of Philosophy, where we are coming and discussing with colleagues and also people living around some philosophical issues related to philosophy of science, but not necessarily. What else? I think that's it.
Okay, great. And James, what about you?
Yeah, so I'm from Melbourne, Australia. I have a background in, I guess, undergrad in physics and biology, and I'm just starting a PhD in neuroscience at the moment. And I have an interest in questions of philosophy and Christian apologetics. So I've written a book called Unreasonable Faith, where I critique some of the arguments of William Lane Craig. And I also do YouTube videos on my own channel and some other channels responding to some apologetic arguments. So yeah, happy to be here and chat about this topic.
Thanks. So let's start. Alexey, you have 20 minutes for opening statement.
Mm-hmm. Let me share the screen. Okay, share. And now. Mm-hmm. Play slideshow. Wait a minute. So here on. Okay. Hello, everybody. Thank you, Misha, for organizing this debate. Thank you, James, for coming and agreeing to discuss my Pythagorean argument for the grand design of our universe, of the superior mind. And Misha, do you hear me well?
Yes.
Okay. Essentially, the material of my talk are concentrated on a few English written articles. One of them is Genesis of Pythagorean Universe, which got an award of FQXI contest and written together with Lev. And it is available in the Pythagorean Universe. And it is written, it is in the Pythagoreanuniverse.com. Another essay also written with Lev is called Metaphysical Status of Physical Laws. We presented it in the conference of International Society of Neoplatonic Studies, and it is published among selected papers of this conference a couple of years ago. So my Russian essays are available for Russian-speaking people. At snob.ru, where I publish a lot of my essays, and also many of my essays are published in Russian literary journals. Grand design is a wording which I borrow from Stephen Hawking and Leonard Mlodinov, which they used sort of ironically because they do not believe that the universe is designed by some divinity. So let me quote them. Because there is a law such as gravity, the universe can and will create itself from nothing. That's Hawking and Mlodinov. It is not necessary to invoke God to light the blue touch paper and set the universe going. Graham Carmelo, the science writer and historical of science, comment on this. God did not create the universe, Stephen Hawking revealed yesterday. The point is, he says, that our universe followed inevitably from the laws of nature. But we might ask, where did they come from, the laws? However, thinking of younger Hawking was deeper. Let me compare, you may compare yourself with a quotation from his famous Brief History of Time, published in 1988. Quote, even if there is only one possible united theory, it is just a set of rules and equations. What is it that breathes fire into the equations and makes a universe for them to describe? The usual approach of science is constructing a mathematical model, cannot answer the questions of why there should be a universe for the model to describe. Why does the universe go to all the bother of existing? Is a unified theory so compelling that it brings about its own existence? Or does it need a creator? And if so, does he have any other effect on the universe? And who created him? So this is a thinking of younger Hawking. I think it is deeper. As you may judge from this quotation from Hawking, he sees that reference to the laws of nature is insufficient for explanation of the universe. You need something more, maybe deeper. I think that the first thinker who stressed this question of insufficiency of the laws of nature was Ludwig Wittgenstein, Austrian philosopher of the last century. Let me quote from his famous Tractatus Logica Philosophicus, published in 1921. Quote, the whole modern conception of the world is founded on the illusion that the so-called laws of nature are the explanations of natural phenomena. Thus, people today stop at the laws of nature, treating them as something inviolable, just as God and fate were treated in the past ages. And in fact, both are right and both wrong. Though the view of the ancients is clearer insofar as they have a clear and acknowledged terminus, while the modern system tries to make it look as if everything were explained. So he expressed it in 1921. Let's speak a little bit more about physics. Physics is a science searching for fundamental laws of nature and applying this knowledge to explanation of natural phenomena and in technical inventions. The laws are sought for as mathematical forms, as mathematical axioms of nature, we may talk. You may remember from school, second law of mechanics of Newton, F equals ma, and the law of gravity. But let me ask a question. How Newton guessed, how did he find this law of gravity, for instance? How he could know that 1 over r squared is a proper dependence on the distances? How many formulas did he try before he came to this one? Well, as far as we know, this one was his first attempt, and the attempt was successful. What was the ground of this guess? How he guessed it should be 1 over r squared? Well, he was led by a sort of naive analogy, we may say, based on the same law of elimination of a letter, say, by a candle light. If you will go twice further from your candle, you will need 4 more candles to have the same illumination. So this is sort of naive idea, and amazingly, this naive idea worked. So how Newton realized that this law is correct? He built calculus and used these 2 formulas, F equals ma and F equals mm divided by r squared. And what he got elliptical orbits with all the 3 laws of Kepler derived from these 2 formulas. So it confirmed that the formula for that both formulas are correct. The model is correct. So the formulas are simple and sort of self-suggesting. They obey certain symmetries, what we call flux preservation. So 1 over r squared, this formula obeys flux preservation as for the light. This was just the first example, but later great discoveries were essentially the same. James Clerk Maxwell wrote his equations based on the symmetry between electric and magnetic field. He added electric term on the right-hand side of the last equation and predicted radio waves. Now, these Maxwell equations are written even in more simple way, because deeper symmetries, which Maxwell did not see, were realized in these equations, which you may see on the right. Lorentz force is also written, was already written in rather simple way, but now it's written even simpler. Schrödinger equation, which is a core equation of quantum mechanics. This is for atomic spectrum, hydrogen atom, and all other atoms actually are consequences of that. It's also very simple equation, very symmetric. General relativity. This is the Hilbert action of general relativity, and it is written in very simple, mathematically clear and symmetric form. And that's how Einstein and Hilbert, they actually working together. They came to general relativity. They were led by mathematical intuition. So the character of the physical laws is very special. The laws are not only fine-tuned for life, as many people discuss, and I know that James discussed it several times, debated several times, but they are discoverable structures. What does it mean for the laws to be discoverable structures? They expressed by short formulas. They are reasonable and elegant. They obey symmetries and invariances, expected and unexpected. They are universal, valid for enormous ranges of distances, times, energies. They are very precise at the same time. Up to 12 digits, this is the best number for today is 12 digits for magnetic moment of electron. And also the accuracy of general relativity is extremely high. They are ordered by discoverability. The closer to us, the simpler. So classical mechanics is simpler than quantum mechanics, mathematically simpler, and conceptually simpler than quantum mechanics and general special relativity. And they are asymptotically exact. Newtonian physics is a mathematical limit of special relativity, general relativity, and quantum mechanics. But they are simple, elegant, but not too simple. They are still barely discoverable. So they were at the edge of ability of the founding fathers to discover them. It was hard, still hard. So they were at the edge. And on top of this, they are anthropic, using the term in the same way as anthropic principle. They are compatible with life and thinking, living, and with thinking living beings. I make about discoverability, I'd like to use a quotation from a wonderful book of Gonzalez and Richards, The Privileged Planet, published 2004. Like an excellent tutor, the universe has not been so demanding as to ensure failure, but rather has allowed us to succeed while still presenting us with worthy challenges. The laws combine in themselves a sufficient elegance to make them discoverable with sufficient complexity to produce the richness of life, including the beings who will be able to discover the laws. We call this discoverability principle, and the universe obeying it, we call Pythagorean. So we live in Pythagorean universe. At what degree is it Pythagorean, you may ask? Well, in huge degrees. The span of scientific cognition comprises today about 45 orders of magnitude. From the size of the visible universe, it's about 10 to the 26 meters, to the scale smaller than that of the top quark and Higgs boson, that's 10 to the minus 19 scale, 10 to the minus 19 meters. If you will divide the big number to small number, you will have 10 to the 45. This is the scale of human understanding of the universe. It doesn't mean that we understand everything, but it means that the span is this, and we understand something important for the whole range of cognition. This would not be possible unless the laws were of this very special character. Even a little increase in complexity of laws would create a tremendous jump in difficulty of their discovery. Remember, they were really barely discoverable. which everyone may understand if read the history of scientific discoveries. On the other hand, were the laws just a bit simpler, life would be hardly possible, not to mention thinking beings. Thus, the laws belong to a tight set of the intersection of complexity and simplicity requirements. Maybe there is just one set of laws there. Okay, what happened? Okay, the only explanation for the laws to belong to this tight set of mathematical forms to be discoverable is that they come from a superior mind, I think, which created our universe capable to not only be inhabited by intelligent beings, but cosmically recognized by them. Who created the creator? Asked Hawking, and many people are asking the same question with him. To avoid an infinite regress, the terminus of being, understanding, and meaning should be postulated. What can be reasonably accepted as the terminus, and what cannot? Nothing limited and contingent can be, because it would be a derogation of reason, triumph of absurdity. In fact, we don't have many reasonable candidates to this position. Since Plato, the leading philosophical schools of the West accepted it as one all-good God. To create the world, he goes out of himself, possibly by means of his agents. Christianity understood him as all love as well. The Trinity concept follows from that. The key motivation for creation of reasonable beings can be seen as God's willingness to be a father of growing children. The free will of the children makes the world not fully predictable to the father, since the creative children can surprise him, making the universe genuinely interesting for him. The first person, I think, who suggested an answer to the Wittgenstein question, why the laws are what they are, was Freeman Dyson in his book, Infinite in All Directions, published in 1988. Freeman Dyson is a famous physicist. He is actually one of the authors of quantum electrodynamics, working closely with Richard Feynman at that time after the World War II. Let me quote from this book his answer to the Wittgenstein question, why the laws are what they are. The principle of maximum diversity, this is the principle which Dyson actually suggests, says that the laws of nature and the initial conditions at the beginning of time are such as to make the universe as interesting as possible. As a result, life is possible, but not too easy. Maximum diversity often leads to maximum stress. In the end, we survive, but only by the skin of our teeth. Laws, this is about the problem of evil, by the way. Laws of nature are explained if it can be established that they must be as they are in order to allow the existence of theoretical physicists to speculate about them. It should not, it formulated like a funny joke, but it's actually very important because all the technical progress which we have, it has in its core great discoveries in fundamental physics, and it is a part of principle of maximum diversity of Freeman Dyson. But at the same year, another person suggested the same explanation, the same answer, why the laws are what they are. It was Stephen Hawking again, in the same book, A Brief History of Time. Again, I'm quoting Hawking third time. Quote, Einstein once asked the question, how much choice did God have in constructing the universe? Let me say from myself, he said it in 1925. Continue quotation of Hawking. He would, of course, still have had the freedom to choose the laws that the universe obeys. This, however, may not really have been all that much of a choice. There may well be only one or a small number of complete unified theories that are self-consistent and allow the existence of structures as complicated as human beings who can investigate the laws of the universe and ask about the nature of God. So you may see that it is essentially the same answer as Dyson's. Maybe Dyson a little bit go a little bit further because he suggests the principle of maximal diversity, which does cover more than the question about laws. To be discoverable is not the same as to be actually discovered, however. The latter requires not only objective possibility, but also subjective effort, rooted in the faith, in the possibility of the fundamental discovery and its highest value, even sacredness. Let's hear Einstein for this purpose. quotation from Einstein from his article 1948. The interpretation of religion, as here advanced, implies a dependence of science on the religious attitude, a relation which, in our predominantly materialistic age, is only too easily overlooked. While it is true that scientific results are entirely independent from religious or moral considerations, those individuals to whom we owe the great creative achievements of science were all of them imbued with a truly religious conviction that this universe of ours is something perfect and susceptible to the rational striving for knowledge. If this conviction had not been a strongly emotional one, and if those searching for knowledge had not been inspired by Spinoza's Amor Dei Intellectualis, they would hardly have been capable of that untiring devotion which alone enables man to attain his greatest achievements. This firm belief, a belief bound up with deep feeling in a superior mind that reveals itself in the world of experience, represents my conception of God. Not only his, actually, if you will read philosophical papers of fathers of science, starting from Galileo and up to Heisenberg, you will see that Einstein expressed something common in general. I'm presenting essentially the same, but in less poetic, more analytical way. The structure of this attitude to reality, of this worldview, which we call Pythagorean faith. But in fact, it is actually biblical Platonism. The core worldview common to the founding fathers of physics, biblical Platonism, grants the possibility and sacredness of cosmic cognition. We call it the Pythagorean faith. And the structure, it's my structure with left and we think this is reflect reality. So first, theism. The world has an author, and he is omnibenevolent and omnipotent God. Second, God is transcendent, while the universe is neither divine nor alive. Third, humans in their core are images and similarities or children of God. Fourth, mathematics belongs to the mind of God, and it is accessible to man. Fifth, matter is structured and determined by elegant mathematical forms. I think that's all the most important part and general to all fathers of science of the Pythagorean faith. This faith was the metaphysical and ethical foundation for the fathers of physics. Its truth, as of any faith, can be judged by its fruits, by the value of 45 orders of cosmic cognition and its consequences. The contemporary civilization is actually a consequence. My talk actually requires at least mentioning two great works related to this Pythagorean topic. An article of Eugen Wigner, The Unreasonable Effectiveness of Mathematics and Natural Science. Eugen Wigner is one of the fathers of quantum mechanics, published in 1960. And the book of philosopher Mark Steiner, who recently passed away, The Applicability of Mathematics as a Philosophical Problem, who developed further Wigner's ideas. Summary, my Pythagorean argument consists of two parts, objective and subjective. Objective, with their very special character, the fundamental laws of the universe may only be purposefully designed to be both anthropic and discoverable by this entropy. Subjective, the key role in the fundamental discoveries was played by biblical Platonism, what we call the Pythagorean faith. Scientific and technological progress is a long-term fruit of this faith by which its truth should be judged. Both parts of the argument suggest no more than one reasonable answer, I think, to the question, why is the universe Pythagorean? It was designed by superior mind, which could be an aspect, emanation, or a son of an ultimate deity, the one all good God. And that's all what I have, guys.
Okay, thanks.
Now I am stopping sharing, stop sharing, okay.
Okay, actually, you're 1 minute late, so James, you have plus 1 minute, if you will. Okay, James, let's start.
Sure. So let me I just got a few slides to share here. Let me just get that set up. Let me see. Yeah, this will do. Is that working?
Yes, yes.
Mm-hmm.
You see that? All right. So thanks for the opportunity to discuss this topic. I hadn't heard this particular formulation of this sort of argument before, so it's interesting to look at. I don't know if I'll go for the full 20 minutes. We'll see how we go. I'm just going to make a few general remarks, articulating how I think about these sorts of issues and maybe responding to a couple of points that Alexey mentioned in his introduction. Sorry, I just put these slides together recently, so I might just reorder them a little bit. So let me talk a little bit about how I think about the laws of nature. So I think of laws of nature as, and Alexey just gave a bunch of examples of these, you know, like quantum theory and general relativity, and Newtonian mechanics is an older one. So these sorts of things. I take this to be abstract descriptions of how the material world behaves, or how parts of the material world behave. In particular, I don't take the laws of nature to be causal in any way. So I don't think that they make anything happen. I don't think that laws have causal powers. I think they're abstractions, and they're descriptions of aspects of reality. So this means that in a sense, we devise the laws of nature, we come up with them, but obviously they have to be empirically adequate. They have to be able to make predictions and be consistent with the observations that we make of the material world. And as we acquire more understanding and develop our theories, the laws improve and become more precise, as we've seen, for example, from the development of going from Newtonian mechanics through quantum mechanics and relativity. And, you know, hopefully one day we'll get to a quantum theory of gravity, which will be, you know, further apply the theories into further contexts that they don't currently work in. Another thing that I think is important to mention is the sort of place of mathematics. So although there's many issues there that go beyond what we're really talking about today, I do think that mathematics has empirical content in a manner of speaking. That is, many of the fundamental concepts that we deploy in mathematics, such as space and number, sets and such, are derived from, or at least inspired by, experience that we have in the world. And interestingly, I noted that the volume that Alexey's essay was published in, the what was it called again? Trick or Truth: The Mysterious Connection Between Physics and Mathematics. There are a number of articles in this volume that actually talk about that, this idea of mathematics having empirical content. So I found that sort of interesting for readers who might, or viewers who might be interested in having a read of that. But anyway, and the other point relevant to that is mathematics is sometimes developed purely for, purely for interest, or purely to solve abstract mathematical problems. But sometimes it is also developed with specific applications in mind. And I think a good example of this is the development of calculus by Newton and Leibniz, or at least by Newton. I'm not sure what Leibniz's motivation was, but Newton developed calculus with the specific motivation of applying that to describe his theories of motion that he was developing. And for this reason, I think it's sort of not as surprising that there's often a connection between our mathematics and the laws of nature that we derive or devise, because of the empirical content in mathematics and the fact that it's often developed for the purposes of specific applications. I mean, there's more to say about that, obviously. For example, mathematics is an extremely abstract discipline. Often we use it to describe, for example, the structure of space, so like geometry, or we have descriptions of symmetry, so say group theory, and those find application in the laws of nature because many of those principles are also applicable because they're so abstract. So I don't think there's anything particularly mysterious or unreasonable about the applicability of mathematics in physical theories, unlike Wigner, who seems to think that there was. I think it's about the same as saying it's unexpectedly, that the use of language, like natural language, is unexpectedly or unreasonably effective in describing the laws of nature, because although doing the calculations just by writing words out would be difficult, the concepts can be explained, and if you go to lectures, are explained in words, right? And we talk about things and share the knowledge, and we draw diagrams. These are all parts of how we convey and develop our understanding of the laws of nature. And I mean, no one seems especially surprised that these tools are effective. They obviously have limits, but they're still very effective in helping us develop and convey our understandings of the laws of nature. And I see mathematics as really just an extension of that, as a tool that we've developed that helps us to express particularly abstract notions, you know, of space and of geometry and number and things like that. So that's the relationship I see between mathematics and the world. Also, a note on the equations themselves, which Alexey sort of discussed in a few different ways. So, although the equations of some of the fundamental laws, say Schrodinger's equation was an example that was given, or Einstein's equations in general relativity. I forget if that was given as an example, but that could be another one. Those equations can be written in relatively simple forms, though I think that there's often disguises the actual complexity of the equations. In particular, because often special symbols have to be developed in order to, or notation has to be developed in order to condense a lot of the complexity into fairly concise formalisms. And maybe I'll actually show some examples of that now, just sort of move this slide forward. I wanted to put another one here, but I didn't have the time. This is just an example that I like to give of how actually not simple the equations are. So this, I hope, unless I've made some mistakes here, because this was my own writing out, but this is a Schrodinger's equation solved for the wave function of a hydrogen atom. So that's the simplest possible case of a, an atomic structure. This basically just describes to put it simply, the probability, or the square of this technically, that describes the probability of finding an electron in a particular position around the nucleus in a hydrogen atom, written out explicitly in all of the functional forms. Usually it's written in an abbreviated form, but I've just tried to expand it out fully to show how complicated it is. I mean, I should say this is written in the spherical coordinates. So if you use a different coordinate system, it will look a bit different. But I mean, that's another example of how the form the equations takes is sort of dependent on our choices of things. But the point I want to make here is this is the only case where we can actually solve Schrodinger's equation for a sort of an atomic system or molecular system explicitly as a function like this. For other cases where you need to use iterative numerical approximations, which are exceptionally complicated and very time consuming. And these sort of, I mean, that's just one example. It's similar in general relativity. The equations of general relativity, I wanted to give some examples, but can be written in fairly concise form, but actually solving them for anything other than the most simple symmetrical systems is also largely intractable. You have to make a lot of assumptions and do a lot of complicated approximations. And it's almost a miracle that we can get anything out of these equations at all, because they're often just so difficult to actually solve. Even solving Schrodinger's equation for a small molecule requires solving millions and millions of integrals on supercomputers. Well, computers get more powerful, so you can do it on a home PC these days. But and even then, there's still approximations and the solutions aren't quite right, because we have to always make assumptions at different stages to get anything out of these equations. So to me, this all points to the fact that these equations are things that we've developed, and we do our best to get something out of the equations in terms of empirical content. But doing that is very difficult and requires a lot of tinkering, a lot of special domain knowledge, a lot of particular assumptions, and often a lot of computing hardware these days. Oops, I didn't mean to put that there. This is another example of this. So this is taken from Lily Marconi's, I think, a paper she wrote on this. This is a fully written out form of the Lagrangian of the standard model, which but basically tells us about the different forces and fields that are operative in quantum field theory of the standard model. So the four fundamental forces of the strong force, the weak nuclear force, electromagnetism, and, well, actually not gravity, but that would be the other one, because we don't have a quantum theory of gravity yet. Anyway, the point is not to go through all these details, obviously. I mean, I'm not an expert on this, but this is extraordinarily complicated. Normally, you don't write it out in this form. Normally, you just work with pieces of it at a time, or you'd condense the notation. I think this was just written out fully to sort of illustrate it. I mean, elegance is a relative term, and it's sort of subjective, but I don't see this as especially elegant. There are certainly elegances here because there are deep symmetries that are embodied in this, although, we can discuss the reasons for some of those. But again, this is intractable in general. To solve this, we have to have very particular, generally experimental setups in which we set up a particular type of interaction. We kind of focus on that. And then there are problems with infinities that appear in the equations, which we have to develop special tools to solve. That's called renormalization. And that there's ways we've worked around this, but this has taken decades and decades to develop all this formalism and work out ways of actually getting empirical content out of it. And we can, and again, in general, you can't use this for very complex systems. It's only for quite simple types of interactions that this is typically tractable. So the point I wanted to make as a result of that, just a few examples there, is that although you can write these equations in simple forms, I think that's actually misleading, because that's really using a lot of sort of condensed notation, or you can write the equation, but you can't necessarily solve it in a simple form, which is actually what's needed in order to describe the system of interest. And so I just don't get the maybe it's almost an aesthetic point that the equations are so simple and elegant and describe this sort of underlying, I don't know, beauty or something in the world. I mean, there's something to that, but to me, it just looks like when I look at these sort of stuff that they are things that we have developed to explain the complexity of the world, and they're extremely difficult to get anything in terms of empirical content out of them in most applications. There are some special ones where, you know, we can make assumptions and we can get good solutions, but in general, that's very, very difficult to do. So those are general reflections on the laws of nature and mathematics and the relationship of that to the physical world. Now some general reflections on the place of God in all of this. So I don't think God is a good explanation for much of anything, and sort of the laws of nature and their mathematizability it would certainly fall under that. So I don't think God explains why the laws of nature are as they are. I mean, obviously, it's going to depend a little bit on our specific understanding of God. So hopefully, Alexey and I can maybe have a discussion about that a bit later, because I don't know precisely what he thinks about this. But from my point of view, it's not really clear why God created anything at all. So this is one question I have. If God is sort of perfectly self-sufficient and doesn't sort of lack anything, then why would he create anything? It doesn't seem like that he can serve any of his purposes by creating something, because there's nothing that he sort of needs that creating would provide. So that's a bit of a puzzle for me, why God even creates anything at all. But suppose that God does want to create something. Well, why would he create a material universe? God himself is not material, again, in the classical way to think about it. And I mean, I don't know what Alexey thinks about this, but at least a lot of Christians have thought that there's some sort of immaterial aspect to human cognition, or to human minds or souls or something like that. Or even if not for humans, at least that there are angelic beings or other types of entities that aren't material. So why wouldn't God just create those if that's what he's interested in? What is the material universe kind of doing for God? What does it add? What purposes are served by creating that? So that's a bit of a puzzle for me. Less clear still as to why God created these particular laws and constants. I mean, God could create any presumably logically consistent set of laws and constants. Why? I mean, why this? Like, what's the explanation for why God created that with these particular, this is the equation, these are the constants. Why that instead of literally anything else? I mean, even if we run a fine-tuning argument to explain why these constants have the value, that doesn't explain why the equations have the form that they do, which again, presumably God could create any logically consistent set of equations to describe the universe, or indeed a universe that is described by very different types of mathematics than the one we have. And so none of those things are clear to me, and that's why I think that God is not a good explanation for any of this. To be clear, I don't have an explanation for why, why these equations or these constants other than any others. I just don't think God provides one either. So I think that perhaps I've actually got a few possible options here. Perhaps the universe is just necessary, which would include the constants and the laws of nature, which means that they couldn't have been any other way. Philosophers like Graham Oppy have defended this view. Perhaps there's a multiverse of different sort of universes or parts of the universe or something that have different constants or maybe even different laws. I know that Alexey's talked a bit about that in the paper that I read, at least. God, I've mentioned as a fourth explanation there. Perhaps there's some unknown physical mechanism that gives rise or explains why these equations and all these constants pertain. That would be appealing to perhaps further developments in physics or future discoveries it would make, perhaps a unified theory of everything or something. And then 5 is some sort of alternative hypothesis that appeals to something that's outside the natural order, but not God. So I don't really know what that would look like. Perhaps we can appeal to concepts like the Tao from Chinese philosophy, or Brahman, which is a little bit like God, but different from Hindu philosophy. Or, I mean, who knows really? Like, I don't necessarily think that we should expect to have a good understanding of why the laws of physics are the way that they are, which, remember, on my understanding is just asking why are things like this in the general sense? Because laws of physics just describe nature. So like, why are there electrons? I mean, or why is there electromagnetic force? I'm not sure we should expect to have the ability to answer that sort of question. I mean, I don't know how we could get information about that. That's not we can compare different universes. So I guess the point I'm making is there are different options on the table here. I don't think that any of them are very good, and so I'm not going to defend any of them particularly strongly. My main argument is I don't think we can answer this question, and maybe it doesn't even have an answer. But if we are going to postulate God as an explanation, I think we need to seriously consider these issues. And well, at least in my interactions before, I've not been very satisfied with the responses there. So hopefully we can discuss this more going forward. One final point that I will make just on the basis of what Alexey was saying earlier is that we have that mathematical equations or entities or structures exist in God's mind in some sense, but we can access them. I'm quite puzzled about that, because if these mathematical forms exist in God's mind, I'm not sure how we can access them. Like, what are we doing if I write down this equation and this somehow refers to mathematical structures that exist in God's mind? I mean, is there some sort of causal interaction there between the concept in God's mind and what I'm writing out? Or is he enabling me to do this in some way by putting the concept in my mind? It's not really clear what's happening or how that's supposed to work, and why we need to postulate God in the first place, other than instead of just saying these are based on abstractions that humans have developed over time. So that's another thing that I think is a bit puzzling. Anyway, so I think that that's getting close to 20 minutes, and that's mostly what I wanted to talk about. I've just got a little plug here to my book that I mentioned before, and also do a science podcast. If anyone's interested in either of those things, you can check those out. And I think I'll end it there. So thanks everyone, and looking forward to continuing this discussion.
Okay, thanks, Jay. So we're now going to rebuttal period, and Alexey, you have 10 minutes for your response.
Yeah, so I do not see that James actually addressed that sort of logic, which I presented as a proof of grand design of our universe by superior mind. So he suggested his own problems in his own ground, which could be addressed separately or not, but I do not see an adequate response to my logic and my argument. So starting from the laws are complex, say James is saying, and he's suggesting some sort of a bunch of formulas, just illustrating how complex are laws, how laws are complex. But what I'm saying, following Wigner, Einstein, and other fathers of science, that the laws are simple and elegant because they are axioms of nature. Axioms of nature are simple because they are based on clear mathematical ideas of symmetry, elegance, etc. Solutions are complicated in many cases, and in many cases we don't know how to apply the laws because it requires a lot of efforts, maybe supercomputers, etc. I'm not saying about solutions of the laws, how to apply them to one or another problem. It's hard. I know it by my profession. I work in this. I have my hard work for my bread. I know this. You James, do not need to tell me how hard it to solve equations. I am doing this in my profession. But I'm stressing again the point. This is the point of Eugen Wigner, Albert Einstein, all great fathers of science. The axioms of nature are elegant and simple in their core. That's how they were discovered. That's how they were discovered. If the axiom of nature was that long, which you showed us, it would be never discovered. And these formulas which you show is just a combination of different contributions to the material world. Of course, if you will take into account everything, if you will write, for instance, Schrödinger equation even for atom of gold, you will need to and put specific term for each electron. You will have that long equation. You would not longer than you showed, but this is not the point. The point is the axioms are elegant. This is the point that relates to discoverability. Solutions is hard. So this is not real. Your objection about complexity of laws does not relate to the point. And your big Lagrange, and it's not about what I'm talking about. So then God does not explain. This is a point of James. But I'm saying that the laws are so specific. They belong to very tight and small group of mathematical forms. Were they a little bit more complicated, they would be probably never discovered, because already they required a lot of effort. At the age of ability of genius, fathers of science, they were discovered. So Were they a little bit more complex, more complicated, they probably would be never discovered. Were they a little bit more simple, they would not be compatible with life. So they belong to the very tight group, very small group. Actually, their belonging to this group was presumed by fathers of science, what I'm calling Pythagorean phase. They searched for this sort of equations, simple, elegant, mathematically beautiful, and they found them. So the phase was rewarded by result. I did not hear in your response any idea about this. So, but then how could you explain that the laws belong to the so tiny, small group? Maybe we don't know. Maybe it is only, maybe any other laws would not be compatible with thinking beings in the universe, appearing in the universe, and able to discover the laws of their universe. You see, there is a circle, there is a sort of self-consistency in our universe, cognitive self-consistency. It's a very special thing. Maybe other laws just do not exist. So you're suggesting, James, 4 or 5 alternative ideas of explanation of the laws. Necessity. I do not know what does it mean, necessity. Necessity in any system, in any formal system, follows from certain axiomatics. If you do not fix axiomatics, I do not know what necessity means. It's meaningless concept. But if you fix specific axiomatics, like, for instance, the axioms of Euclidean geometry, then you will have, by necessity, say, Pythagoras theorem correct. But you need theorems of Euclid geometry to make Pythagoras theorem necessarily correct. Without these axioms, Pythagoras theorem not necessarily correct. But then the question is what? So necessity by itself, it's meaningless concept. So multiverse I actually criticized in the paper as a possible explanation. Max Tegmark suggested the multiverse explanation of discoverability, and he himself actually refuted it, because he says that according to multiverse hypothesis, the laws of our universe should not be discoverable. He realized it, and he actually refuted this. We just worked a little bit more on this issue, but essentially Max Tegmark said that, refuted himself, and also Alexander Vilenkin also criticized this point, showing that the laws would not be discoverable in the multiverse case, unless you will assume already in the multiverse, like string theory or something like that, already elegant theory. But then, well, if you presume as an axiom of your multiverse the elegant theory, then it will be elegant, but this will be a circular logic. It's not an explanation. It's alternative non-natural description. So I am saying that upon superior mind, the only reasonable explanation. Nobody suggests something else. All other possible explanations fail. But to say that superior mind, it's actually not the whole story. Superior mind, and then who created the creator, and all sorts of questions. How the superior mind relates to the reasonable terminus of everything existent, like all good God. This is a question, I agree, but it is reasonable to discuss this question only after we agree that the superior mind created our universe. If you agree, if you would agree with my argument that the superior mind created our universe, we may discuss about relation of this superior mind to terminus of being, like Plato postulated and Christian theologians postulated after him, etc., accepted and enriching it with the all love idea. So that's and about access to God's mind. This is the belief of Pythagorean faith. That's otherwise, if you do not have access to God's mind, you would not believe that you would be able to discover the laws of universe. This is a point of the faith. I am not saying that we proved our access to God's mind. I'm saying slightly different way. I'm saying that Pythagorean faith postulated this, and this faith had great fruits. Okay, so I think I responded to James' statements.
Okay, thank you, Alexey. Let's turn to James. James, you have 10 minutes for rebuttal.
Cool. So let me just bring up this slide again, just more for illustration than anything else. So I'm trying to understand the sort of thrust of the argument here that Alexey's made. So my opening remarks are intended a little bit as a response, but mostly just as sort of a setting out of how I think about these problems. So let's consider what Alexey said then, that I take it that what he is arguing, hopefully I've got this right, is that we observe that the laws of nature that describe the universe are have relatively simple and elegant forms, and also that they're discoverable. I mean, obviously, we'd have to discover them to know that. So discoverability and sort of elegant simplicity are the two sort of key features here, and that these are best explained by appealing to a creator who sort of made the universe and made it have these forms and these mathematical forms that exist in his mind in some sense. Okay, so let's take the two things that we're trying to explain, the simplicity and elegance of the equations and their discoverability, and consider these. So let's start with simplicity and elegance. So one of the problems I have with simplicity and elegance is that they seem to be largely aesthetic criteria. Simplicity maybe a little bit less. Elegance, I think, is explicitly an aesthetic criterion. So there's already some sort of vagueness there. I mean, if Alexey says they're elegant and I say, I mean, I'm not just saying Alexey said. Obviously, plenty of physicists have said this as well. But I mean, 50 physicists could say that the equations are elegant, and I could say that they're not. And like, well, how can we decide who's right there? A physicist, experts in like elegance? I don't even know what that means. But that's not the main point I want to make. I just want to highlight that elegance is a bit vague, and I don't really know what we're talking about here. But let's now consider the question with respect to these two cases here. So I think this equation here, which is one way of writing Schrodinger's equation. That's one example that Alexey mentioned. It's a sort of fundamental equation in quantum mechanics. I mean, undeniably, that's a pretty simple equation, right? Basically, all of this is saying is that the wave function of some system operated on by the Hamiltonian operator returns the wave function of that system multiplied by the energy of that state. So that's like pretty simple, right? It's quite a simple eigenfunction equation there. That's pretty remarkable. So how can we explain that? Well, I guess I just think about this a little bit differently to the way Alexey does, because Alexey in his response made a distinction between equations and the solutions to the equations. He said that, sure, the solutions are often very complicated and maybe can be intractable in different cases, but the equations themselves are quite simple. And I don't mean to sound sort of condescending in maybe some of my remarks, because I know Alexey's more familiar with this stuff than I am, right? But I'm just sort of articulating how I think about it. So I apologize if I ever come across that way. Or if I explain these things, that's obviously for the viewer as well. The point that I want to make there is this equation here. Let's take Schrodinger's equation as this example. This is a simple form, but what follows from that? Like the equation is important, but in and itself, it doesn't really tell us that much about a physical system. Like what do we learn by just looking at that? I contend not a whole lot. I mean, you might say, well, yes, but it tells us about the abstract relationship between Hamiltonians and the energy eigenvalues. But the Hamiltonian is just defined as an operator that gives back the energy. Like, so it's I just contend it's not in itself that informative. What's informative is a solution to that. That allows you to make empirical predictions. It actually constitutes the empirical content of the theory, and that's also the way it's tested. And so I just think that equations like this are pretty cool and obviously useful. We need them. But the fact that they take a simple form is just, I don't really see the significance of that. It's the solutions that are actually useful and interesting and empirically testable. All this says is that there is some operator, call it a function, which operating on another, operating on a quantum state of a system gives back the energy times that quantum state. If we don't know what H is, if we don't know what the psi is, and we don't know what the energy is, it's just really a bunch of symbols. Like what is so, I guess I'm just not seeing what the question is, like why it takes that form instead of a different form. I mean, I don't have the answer. I don't think Alexey does either. But in terms of the simplicity or elegance, I just don't think that the empirical content, the interesting content is in that equation. And I would say it's the same thing here with Einstein's general relativistic equations. This equation here expresses a relationship between the curvature of the universe and the energy mass content of the universe. That in itself is an interesting relationship, to be sure. But I mean, the specific form of the equation, most of the interesting stuff is is embedded, or stuff. Most of the interesting content here is embedded in these tensors here. And again, it doesn't actually tell us anything empirical about until we can actually get solutions out of it. So let me just explain a little bit more what I mean about that. Remember that I started by saying that I think that laws of physics are descriptions of the way nature works, like the way things behave in nature, or at least parts of nature. So in order to count as a description of how nature behaves, it actually has to describe nature. It has to actually say things about, in this context, things behave this way. In this context, they work that way. These equations here in this very abstract form describe some very abstract relationships that I actually take it are largely the result of the way we've defined concepts, like the way a Hamiltonian operator is defined is kind of relates directly to the fact that it's going to produce an energy eigenvalue. Einstein's equations of general relativity have a key insight that there is a connection between the energy mass content of the universe and its curvature. And that is a very interesting insight, but it doesn't tell us directly how to actually make any predictions or how any specific thing is going to behave. And that's the kind of point I want to make. So to actually describe how the universe behaves or how bits of it behave, you have to actually solve the equations. That is kind of the empirical content. That's the interesting, or the most interesting aspect of the theories. So I guess the point I'm making is, to me, this distinction between the equations being simple, but the solutions being complicated, and we don't need to worry about the solutions being complicated because the equations are simple and that's all that we care about. I just don't really understand that. I guess fundamentally, I just don't get why we would make that distinction, or why we're interested in the one but not the other, when actually, to me, the interesting part is largely in the solutions. I mean, the equations matter themselves. Obviously, you got to have them to solve. I'm just not quite seeing that. So that was the first point about explaining the elegance and simplicity of the equations, because to me, I guess I bundled that up with the solutions as well. And it seems to me that we write these equations because they're useful in developing solutions, which actually allow us to then make predictions in particular contexts. Now, that's often very difficult to do. Sometimes it's easier, sometimes it's harder, and you have to make further assumptions. So to me, these equations are summaries of a whole body of knowledge and procedures that we have. And so because they've been deliberately developed to summarize a whole bunch of stuff and other techniques, it's not surprising that they're written in a simple form, because that's sort of the point of writing them this way, as a sort of a summary. To actually apply them, you can't just leave them in this way. You have to do a lot more to it, and that's when they get really complicated. So I just don't see that there's really much to explain there. I guess that's probably a product of how I'm thinking about it. So that was the first issue: the simplicity and the simplicity and elegance of the equations. The second point was about the discoverability of the equations. So let's talk about that a bit. I'm also a little unclear here about what it is that we're trying to explain, because unless we assume that we know what the true form of the laws of nature are, which I think both of us would agree we haven't, when we don't have a quantum theory of gravity for a start, there's a lot that we don't know what dark energy is, et cetera, then we don't know how much we've discovered of the equations of nature. We only know what we have discovered. We don't know what we haven't discovered. We know some things that we haven't discovered, but maybe there's more and more beyond that. So suppose there's 10 levels of complexity in the laws of nature. What is a level? I'm just giving an illustration here. Suppose Newtonian mechanics is level 1 and quantum mechanics and general relativity is level 2. Maybe there's 8 levels above that we haven't got to yet. And maybe we'll never get to. Maybe there's 100 levels. I don't know how far it goes. Perhaps many of these are not phenomena that we'd ordinarily experience. Like neutrinos, for example, are very light particles that rarely interact with anything. And we've relatively recently discovered them, and they're very hard to detect. Maybe there's much more out there that is just outside of the sorts of things that we would normally detect or interact with, and we will sort of never discover. So the point I'm making is, how do we know how much of the laws of nature have been discovered? We only know what we have discovered. We don't know what we haven't discovered, or at least we don't know how much we haven't discovered. So I'm not sure that. I guess the question from my point of view is, what is surprising? Is it surprising that we've discovered so much of what the true laws of nature are? Because I would just question whether we have. Or is it surprising that we've discovered even as much as we have? But then the question would be, well, how much would we have expected to have discovered? We've had thousands of years of civilization and development of science to get this far, and it's been very difficult. I'm not sure what is the expectation? What is surprising about how much we have discovered? Because it seems, regardless of how much we had discovered, you could just say, well, it's surprising we've got this far. Like in the 17th century or early 18th century, you could say, wow, Newton's theories of motion, it's surprising we could discover that much. And you could make a surprise argument there. But then, in the 21st century, you could say the same thing. In the 23rd century, you could say, wow, it's surprising we've discovered this much. So it seems that this that you could ask the question regardless of how much we've discovered. So I'm not quite sure what we're supposed to be surprised about, or the sort of level of discovery we've had. And sort of bring that back to the question of God. I'm not really sure how the existence of God helps us to understand why we've discovered the amount that we have. Well, first of all, why does God want us to understand the laws of nature? That's unclear to me. But even if he does, why is it that he waited till the 17th century or he set the world up such that we would have to wait until the 17th century to get Newton's laws, until the 20th century to get quantum mechanics and general relativity? And then, I mean, I don't know how, again, maybe we'll never get to a full theory. Maybe we'll get to a quantum theory of gravity next century, or like, who knows, right? Like any possible outcome in terms of when we discovered particular things seems to be equally consistent with the explanation that God set them up for us to discover. Because, well, like, we didn't discover them for ages, but then we discovered some of them, and then we discovered more. I mean, how does God explain why we have this order and sequence of discovery? I'm just completely unclear about that. Likewise, in terms of the elegance, why are the equations this elegant, not more elegant, not less elegant? So I don't think that God is a good explanation, because it seems equally consistent with any outcomes, in addition to the points that I raised earlier about some of the problems with God. I think that the two questions on offer are presented about the elegance and simplicity and the discoverability are just really unclear about what is supposed to be surprising or what we're actually asking. And I just, find it sort of hard to understand what we're even trying to address here. One final point, I think I'm about out of time, but I just wanted to mention that the notion of necessity, Alexey said this is a meaningless concept. I don't really see that it's a meaningless concept. It's a pretty standard idea in philosophy that if something had to be true or is true in every possible world, so that there's no possible world in which it is not the case, then it is necessary. And so Graham Oppy has argued that the laws of nature may simply be necessary, meaning that they are the way they are in every possible world. In which case there's no question about why they take the form that they do, because there's no possibility that they could have been otherwise. I mean, that's not even really a good explanation. That's just a way of saying that they don't need an explanation. But I don't at least see that there's anything meaningless about that, even if we don't agree with it. So anyway, that's all I've got. And looking forward to the next part of the discussion. Close that.
Okay, thank you, James. So we are going to now we are going to my favorite part of this debate is cross-examination and discussion. Okay, we have 30 minutes and 50 minutes for each speaker to ask questions and discuss some problems or topics that you raised. Friends, write your questions in the comments and we will discuss them a little later. Okay, Alexey, you have 50 minutes for questions and some problems that you see.
15 minutes?
Yes, 15
minutes. Quarter of hour. Okay.
Yes.
So I would like to ask a question for James. How do you, James, understand the value of fundamental science? What is the value? How would you explain for lay people, or imagine yourself in Congress of United States or in Australia, trying to convince Congress people, congressmen, congresswomen, to support fundamental science. How would you do this? What is the value of fundamental science which you would try to deliver them? This is an important question, by the way, for all of us who are dealing directly or indirectly with fundamental science. I am dealing with this. I am working in the laboratory which is doing fundamental science. We are talking about issue closely related to fundamental science. How would you support the fundamental science?
That's a
lay person.
Yeah, that's a really good question. I think my answer would differ a little bit depending on who I was talking to. So when you mentioned going to Congress or before Parliament, I'm like, well, that might require a slightly different answer. But I think the short answer would be the value of science, fundamental or otherwise, would be, in my opinion, is to understand the way the world works or things in the world work. And with that understanding, we can then use that to improve our lives, make things better. So that's the one sentence answer.
To make our life better. But you know, there is a huge competition between different scientists, and some of them really dealing with applicable issues like energetics, like ecology, like medicine, and etc., chemistry, which related to real life problems. But fundamental science, contemporary fundamental science, is dealing with the issues which are very, very far away from real needs of people. For the early universe, or particles even smaller than Higgs boson, or higher energy than Higgs boson. And fundamental science requires a lot of investigation, a lot of money actually to support it, because it is actually hard to look at the early universe or to the particles smaller than Higgs boson. And if you will say just to understand nature, well, why not understand nature which is closer to us and which bring us benefits for ecological problems, for energetical problems? Nobody actually expects now. It would be very strange to expect that learning about Higgs boson and smaller particles will bring us benefit for energetics or for ecology. It may, but just accidentally. But from accidental point of view, you may expect it everywhere. From this point of view, fundamental science doesn't have any benefit. So I don't think that this sort of argumentation would work. I think you would not convince with this argument the Congress people. I may give even an example about this. Maybe you know that in the States in the 90s, it was the huge accelerator problem was the project for superconducting super collider was closed by the Congress of the United States. People did not manage to convince Congress people. Scientific community didn't convince Congress people to give sufficient finance to support this accelerator. And the accelerator, what was already in the middle of the way of building, was closed. So it canceled. The project was canceled. And you may read about this story in Steven Weinberg's book. I think it is book of Dream of the Final Series, how he tried to convince Congress people to support SSC. And he says that future generations of men and women will consider that we did something extremely important to understand the fundamental laws of nature. And then some of the congressmen asked, do you mean that are you talking that we are reading the mind of God? And then Steven Weinberg, who was atheist actually, and is atheist, he thought that if he will continue in this way, then project definitely will not have money, because he will tell what he really thinks about God. And he was atheist and mostly concerned with the problem of evil. And then he did not say anything. At that time, this is the story Steven Weinberg himself is telling in his book. And then the project at that year, it was supported by the Congress, but still next year it was closed. So it means that you should deliver something really important to layman people, and to Congress, something really valuable to support fundamental science. And the arguments like, well, it maybe will help us with our everyday problems, it does not work. And the argumentation that just to understand nature doesn't work either. So none of them practically works, because you could not, these values are too weak. But the only value which is really weak, it was a fundamental, the key value of the fundamental science itself, which is essential to the Pythagorean faith. What motivated fathers of science to great discoveries? And Congress people, they suggested Steven Weinberg to use this argument.
Alexey, please formulate in questions so we go on to discuss.
Okay. So maybe I will ask another question.
Well, do you want me to respond to that, or I mean, you can just go, it's your time, so you can go to something else if you'd like.
I don't know what we should do, Misha.
Well, I'll just make a brief comment about that. I don't have any particular expertise or claim to be able to persuade Congress or anyone else about what they should fund. All I would say is that, I mean, I don't know what bearing that has on anything. I mean, maybe your argument about these being in the mind of God is more persuasive to people wanting to fund it. I don't have any reason to believe that, but I mean, it could. I'm not sure that it has any bearing on the truth of the question, I guess, is my point.
Okay. So maybe the next question would be, if the elegance if the mathematical elegance is not an issue, as you tried to suggest, then again the whole motivation of the fathers of science disappears in your explanation. What was the motivation then of according to your views, of the fathers of science for discoveries? If search for mathematical elegance and special community to God is not so important, what was important then for them?
Yeah, so I just want a bit of clarification. When you say the fathers of science, like what sort of time frame? Just a few examples, because I want to understand who I'm talking about.
Yes, the leaders of scientific revolution of 17th century, so Galileo, Descartes, Kepler, Galileo, Descartes, then Newton, Maxwell, then Einstein, Planck, Heisenberg, Bohr. Let me, Pauli, if you want, Dirac.
Okay, yeah. Right. So that's, I just wasn't sure if you were talking in like the ancient Greek context or anything. So
the top figures.
Sure. Well, each of those are different people. They're motivated by different things. Certainly some of them were motivated, maybe all of them. I don't know all biographic cases, to find elegant solutions to equations. This is a deep question in history and philosophy of science about sort of the intellectual development well, particularly in the 17th century, when you're talking about the very beginning of what we would call modern science. So I actually think that, so there was a development in around, let's say, 16th, 17th century of a new way of thinking about things called the mechanical philosophy, which was basically the idea of thinking about the universe as a sort of a clockwork universe, which generally the idea is that God sort of set it up, and then it just sort of operates under its series of causal laws and principles that can be described mathematically. That was not entirely, but relatively new idea, and there's been interesting work written on this. So I think it seems to be the development of this idea and the emergence of people who are interested in solving particular problems, such as Galileo pointing his telescope at the sky and trying to work out, how to understand the the problem of the place of the Earth in the solar system and sun of the solar system and so forth. And, later Newton was looking at laws of motion, and Einstein was looking at, things like the Brownian motion and the photoelectric effect. So there's sort of to answer your question, there's a general sort of substrate of sort of a general philosophical or methodological take on things. And I think the mechanical philosophy in the 17th century was particularly important there and was criticized by some thinkers as being as a sort of taking God too much out of the picture. And then in addition to that, there's the desire of particular individuals to solve specific problems and derive solutions to those, sort of the problem-solving side of it, which is often linked to new experimental results, although not always. So these two things seem to be important for motivating people to answer particular questions. So absolutely, they're looking for generally mathematical and often elegant solutions. There's a lot of reasons to favor that in terms of, say, simplicity. Sort of, there's an Occam's razor argument to be made, and in some cases, and there's just a utility case of simpler equations are easier to work with. So that's a motivating factor as well. But yeah, so I guess there's a complex story to tell about that. And I've just outlined a few things that I think are important. Again, though, I would say the motivations of early scientists could have been, I mean, let's take Newton. Newton had all sorts of crazy beliefs about like Bible codes and stuff like that. That doesn't undermine or really have any bearing on his scientific work. And so for me, the motivations of these people is of interest from a historical point of view, but I don't think it necessarily tells us anything about like the way that nature actually is, or the relationship between mathematics and nature and so forth. That's more of a statement about their psychology and the sociology of their time, rather than like the actual scientific content of their theories, at least in my opinion.
But you disregarded the explanation of motivations, the description of this motivation given by Einstein. And as a person who actually spent a lot of time of research on history of science, I see that Einstein actually is talking not about only himself. He's talking about all the fathers of science, and he's talking about amor Dei intellectualis, intellectual love to God. He is talking about this idea of special communion with God in searching the perfect mathematical forms which govern the nature of the world, etc. So belief.
Was Einstein even a theist
God,
in the way that you are? I don't even. He certainly used language of God, but I don't really think he believed in God as like a mind.
I said I may repeat the quotation of Einstein, which I already suggested. He's telling there quite directly that he believed in a superior mind who created this world. It is just directly. You may read my.
Yeah, well, he said other things as well. I mean. Whether he said that or not is not of great interest to me. I guess viewers can look into that. My understanding is that he said quite a few things about God, and other things that he said seem to conflict with that in my mind, but I'm no expert, so that's fine.
So your explanation of motivation is not compatible with what really fathers of science were telling about themselves. It is invention of people, of skeptical people who did not learn real history of science, and who invented convenient explanation for fathers of science from their skeptical point of view, without deep learning of history of science. This is my point. So your explanation is irrelevant to history.
I mean, I don't think the mechanical philosophy is irrelevant to history. That's pretty widely discussed in terms of understanding the 17th century. But look, even if I'm completely wrong about that, what relevance does that have to your argument? I mean, why does their motivation matter?
Because how we can judge about one or another worldview. In physics, we have falsifiability. We may make experiment and compare theory with experiment. But in metaphysics is not falsifiable. How we may judge about metaphysical ideas, about the ideas that is the world appearing by itself from out of nothing, out of blue somehow, or some super powerful mind created it. This cannot be scientifically falsified, but how you may judge the truth of faith. And the point is that by their fruits you will know them. This is actually a universal principle to judge about truth of faith. And this faith, which I call Pythagorean faith, which is common to all fathers of science, common, its fruit is our civilization, where we live and we're using all these devices. By the way, you said that it is important to solve equations. Of course, it is important, and this brilliant equation is solved in many cases. And the device which we are using is one of just our computers and internet connection is just an example of this solution. There are infinite number of solutions, very many solutions of these fundamental equations. Atoms which we observe from the other side of the universe, they have the same spectrum than atoms in the Earth, and these spectra are calculated, by the way. Spectra of hydrogen atom was calculated right away at the dawn of quantum mechanics, at the very beginning. And it was compared with experiment, and voila, they agree. And then relativistic corrections were taken into account, and all it was based on the elegance principle. You are talking that you don't know what is elegance. Well, you may educate yourself what fathers of science consider it as an elegance, because this led them to discovery. This was very powerful. It was very powerful principle which led to this discovery of equation. It doesn't matter that you don't know. It means that just you did not educate yourself. Educate yourself. And I just mentioned that the elegance means that certain symmetries, invariances, etc., and shortness in form and reasonability, many points, and some limit agreement between theories of more simplistic theories like classical mechanics and higher levels of theories like quantum mechanics, etc. They are limit cases. There are many interesting and deep mathematical relations between them, and this makes the laws very special.
Okay,
very special. They belong
Alexey,
to very tiny group.
we have time.
Okay.
James, if you could answer, and then you 50 minutes go.
Sure. So just some brief comments on those last remarks. So I certainly appreciate that symmetries are very important in physics. I guess we could have a long discussion, which probably is not the most worthwhile thing, about the relationship between symmetries and elegance, because to me, those are different things. But again, we can put that to the side. Also, there are many principles that people have come up with over the centuries that they thought were elegant that are completely wrong. So there was a model of, I don't actually remember who came up with this, forgive me, but there was someone who came up with a model of the solar system where it's like each planet had its own not orbit, but it's like it was related to geometric shapes, and they had all these different geometric shapes in a sort of an ordering. Maybe someone in the chat will remember who that was, but like the point is
Kepler.
They thought that was
Kepler.
Was it Kepler who thought
right.
that? Yeah,
Kepler.
So that was very elegant for him. I mean, and another example would be the circular orbits what's his face? The ancient Greek name escaping me came up with that they thought was the most elegant description. I mean, so elegance can lead us along the right path and lead us astray as well, is sort of the point I'd make about that.
Yeah,
but anyway,
sure.
I felt like there was something else I was going to say, but I've forgotten what that was. So let me then ask you some questions. So I think one of the fundamental questions that I have, which I've sort of been mentioning a few times, is what God let's just say God. What is the relationship between God and, or the explanatory relationship between God and the elegant and discoverable mathematical structures? So that those seem to be the 2 points that you're interested in. So how does God explain the fact that the mathematical structures that we can use to describe the laws of nature are elegant and discoverable?
I actually mentioned this point in my talk. So if you will say just God and nothing else, if you will not add some qualificators to God, what do you mean by what is meant by God? Then of course you cannot nothing in and nothing out. You should imply something more to God that just you don't know which
yeah, sure, that's fine. So I guess I'm asking you to give that.
And yes, but I told you that this Pythagorean faith, it has certain qualifications and specifications of God, which actually follows what Einstein described. And if you will build on this, you will come to something like maximal diversity, most interesting universe of all most interesting of all possible worlds. This idea of Freeman-Dyson. And if you will understood God as a creator of most interesting of all possible worlds, this is development of Leibniz idea, then you will guess that in most interesting of all possible worlds, most likely you may expect that the laws would be discovered by the creatures, because if we discover the design of the designer, it makes the laws much more interesting for him also. For him, imagine yourself on his position. One situation that you have just animal-like creatures, and another you have thinking beings who are understanding gradually, step by step, the idea of the designer, making closer to him, like children, like growing children. God wants to have children. He don't want to be alone. So this, if you will add something to idea of God, do not go just bare idea without any consequences, but consider, say, Pythagorean God, which is compatible, by the way, with Christianity, and I think it is compatible also with Islam, it's compatible with Judaism, and even with Hinduism. I think with Vedanta it is compatible. Then you could make a lot of interesting conclusions. For instance, you may make the conclusion which fathers of science did, fathers of physics, that the laws of nature are built by mathematical equations, and we are able to discover them. So they are simple enough and elegant enough, because people were looking for elegant mathematical forms, not just any mathematical forms, but mathematically elegant. This, of course, does not lead you immediately, right away, to the solution. Of course, you still have a lot of problems, a lot of troubles, and maybe you will not find the solution, but it narrows your search extremely. And it was very important. So fathers of science were looking for elegant solutions, and they found them sometimes right away, like Dirac, for instance. He wrote the equation of quantum electrodynamics, first equation of quantum electrodynamics, and he concluded there should be antimatter, and then antimatter was discovered. And like Einstein, he built his general relativity on a simple, very simple mathematical principle, simple in a sense, not that it is easy to solve, but in a sense that the idea is clear and distinguished and simply formulated. He built the theory on that, and voila, after 100 years, after all, we are observing this gravitational wave. And this theory has extremely high precision. So how it was possible that people, having their prejudices about elegance, discovering the fundamental structure of the world? This is the point.
Yeah, but what I'm asking, I mean, I think we've already talked about that a bit. I'm asking about how God explains it, right? So you've said that, well, if I'm correct in understanding what you said, that a world, so our world is the most interesting possible world.
Of all possible worlds, this is Dyson idea. Dyson.
Yeah.
Dyson.
So okay, so let's take that for the moment. So, and you also said that one that is discoverable, a world that where the laws of nature are discoverable, is more interesting to God. So
Yes.
our existence and discovery is more interesting to God than God sans the universe. I don't understand that.
No. The world where thinking beings not just exist, but able to discover the foundations of the world where they live, fundamental laws of nature, is a lot more interesting than thinking beings are just able to think about their garden, about girls, about boys, etc., but not able to go that far, be able to cognize, to understand, to discover the laws of the universe, of the whole world. This world is much more interesting because it shows the spiritual growth of the creatures. They are not just animal-like creatures able, on top of that, a little bit think about their life. They're able to see the grand design, to discover it. This is a lot more interesting world.
Well, I think that a lot's going to hinge on what you mean by interesting there. And I'm also not sure, you mean interesting for us or interesting for God? Or both?
For God and for us also. Both for us and for God. So for us, because it was inspired, best, not everybody, of course, but some brilliant minds were inspired and served this, and some of them were successful to discover, but also for God. It is interesting to build not just dull world or world very much predictable, but world where free creatures are living. Free creatures already means that they set limit to predictability of the world. Then free creatures can surprise God, can surprise. He don't know. So creating.
Wait, so God doesn't know the future?
Not completely, because because he provided us with free will. Free will means that we are really free. If it is not joke, if it's not illusion, but truly so, it means if we truly are in image and similarity of God, it means that we are creators. We have a creative power, and creative power is unpredictable. We are really have a terminal causes in ourselves. We may create something new and surprise the creator. So the world is not so dull and so predictable and so boring for the God, because without creatures with free will, the world is fully predictable to God. But free will creatures are little gods, growing gods, and they are not completely predictable. They may surprise the God and make the world interesting.
God make a universe that has deterministic equations? I mean, quantum mechanics may not be deterministic, but if what you're saying is that God wants to have free agents who are able to sort of surprise him and act as their own creators, how does so that seems to be the opposite of the fact that the laws of nature are elegant and can be used to predict the future, because that means that we know what's going to happen. It's not a surprise. So if God wants to be like surprised or something, why doesn't he just only make free agents? Why do the laws of nature? I don't see how the laws of nature fit into that.
Well, the laws of nature and associated predictability of the world relates to our ability to build something interesting, to build civilization. When we build in something, we need predictability of things. This computer should be very much predictable, otherwise we would not have this connection and this discussion. Our houses, bridges, railways, airplanes should be very much predictable, otherwise we would not build them. So the condition for creative minds to participate in the creation of the universe is predictability, huge predictability of the material world. That is why laws of nature are predictable, but they should not be completely predictable, because it should be some sort of uncertainty, because otherwise free will would not be possible. So this is paradoxical requirement, and this paradoxical requirement is satisfied in our world. So our laws are predictable, but not totally predictable. There is uncertainty, and this uncertainty opens the door for free will.
But that seems to be what you've said there seems to be equally consistent with a whole range of possible worlds that have some degree of predictability, but not too much. You're just saying it has to be somewhere in the middle, but that there's a huge range of somewhere in the middle. So that's why I don't see how it explains why we do see what we do. Like why do we have the specific laws that we do? It seems that they could be different and still have some degree of predictability and some degree of unpredictability.
Not everything can be predicted. There are many questions we don't know answers, and you mentioned some of them, but the point is not this. The point is that there are a lot of things which can be predicted and expected based on the worldview which I am trying to describe. For instance, discoverability of the laws are explained in this way. And also certainty and uncertainty of the laws should be described. By the way, Epicurus was the first philosopher who, on the ground of free will, predicted that should be some uncertainty in atomic motion. He called it clinamen. The ancient Greek, he took seriously the idea of free will and said that atomic motion, which according to Democritus and Leucippus should be completely deterministic, must not be completely deterministic, should be some uncertainty, because otherwise free will is not possible. He predicted, by the way, he predicted clinamen, which in deeply and philosophically it is quantum mechanical uncertainty. And this prediction is correct. So I am not saying that everything can be predicted. All the problems should be solved. Of course not. But the fundamental features of our world, of our universe, are compatible with this theistic worldview, which I tried to describe. And I don't know any other worldview which is compatible. There's only one.
Yeah, well, that's what I'm trying to work out, because I still don't, I mean, being compatible with and explaining are two very different things. So, I mean, maybe you're not actually claiming that your worldview explains the elegance and simplicity and discoverability, that it's just compatible with them.
It explains on the ground of the assumptions, on the ground of the assumptions of this worldview. And also, by the way, it is compatible with high values. The worldview is responsible not only for predictions, what we can observe, but it is also responsible for ethics and values. Values are not detached from metaphysics. Metaphysics and ethics are entangled strongly. If you, for instance, will say that our universe is just accidentally happened to be livable, anthropic, and accidentally discoverable, is a huge set of universes which are sort of piece of garbage, nothing else, non-living, non-discoverable, with some strange, unreasonable formulas, etc. Then you will actually say that we in big picture, we live in a big pile of junk, and there is no reason, actually, no motivation, no ethical foundation for values to discover the laws of nature. Well, from practical point of view, we still might be interested to discover something which will make our life easier, but not fundamental science. So metaphysics and ethics and strongly entangled with each other. And this picture, which I am trying to describe, this picture is compatible also with high value of fundamental science and cognition and unspiritual growth in general.
Well, so, I mean, the whole issue of values and ethics is a separate point that I don't have time to go into now, but I'm still a bit confused about why we would expect if God created us to be sort of more interesting and because we can do surprising things. But you've said that we need to have an understanding of or at least the laws of nature need to be discoverable for us to do that. But I don't quite follow that, because, I mean, let's say pre-17th century, 16th century, we knew very little about the laws of nature, and we still did lots of interesting and surprising things. I mean, I would presume, right? So I don't see how we need an understanding of the laws of nature. I mean, even for technology, a lot of technology, I mean, modern technology does rely on quantum mechanics and so on, but you can imagine in a different world where we can't actually understand the laws of nature, we just have, I guess, very domain specific, empirically derived rules for, like, well, when you do this, then this happens. Like, it's not as fundamental in terms of our understanding. And still a lot of things like that are used in engineering, I would say. So, like, I mean, that was the case for a lot of technology before the scientific revolution. Maybe you can imagine a world where that was the case, up to the present. And so the point is, you could still have technology. You can still have humans doing a lot of unpredictable stuff without the laws of nature being discoverable, or to any significant extent. So why is that preferable?
Because it makes life and universe even more interesting than without that. I agree with you that life of humans was very interesting already before scientific revolution. But God made the universe even more interesting than you might expect from looking at the 15th or 16th century. The universe is even more interesting. So all the beautiful things and interesting and surprising for God and for people, things which you mentioned, like art of Renaissance and technique of Renaissance, etc., many interesting, poetry, all these beautiful things, very interesting, great. And I'm sure from the point of view which I described, the surprising God, but God made the universe even more interesting than that. He made the universe, the whole universe grand design discoverable for people, showing people their huge cosmic scale. We are cosmic observers. this 45 orders of magnitude shows the scale of human thought. So we are not small inhabitants of this planet or even solar system. We are big inhabitants of the whole universe. 45 orders of magnitude is a scale of human thought, so human beings. That's our scale.
Yeah, but couldn't
And
you
this
argue
is very
that
important?
couldn't you argue
Okay.
that the universe could be, or I guess life, us, would be even more interesting if we didn't understand the laws of nature, because then we just have to work out each particular little system by itself, and there would be no overarching framework, or at least a very minimal ones. Maybe a bit more like biology, where it's just like, you know, lots of specific cases and there's less of an overarching theory. Wouldn't that be even more interesting?
I would not exclude that there are universes where God followed your advice and created the universe where piece by piece, and every piece may had its own maybe laws of nature, or maybe no laws of nature at all, something completely different, maybe some spirits talking and playing with each other, like sort of intellectual games, etc., etc. I wouldn't exclude this. Maybe it's possible, who knows? But our universe, which shows this huge scale of discoverability, surprising for people, that we consider it ourselves. Many people consider us as just piece of, like bacteria. So we are just a little bigger than bacteria. So we are inhabitants of one little planet in the middle of nowhere, etc., etc. Well, it's not true. It's surprising revelation of the fundamental science that we are cosmic creatures. Our size is the size of the universe. That's our scale already today. Doesn't matter whatever will be discovered tomorrow or day after tomorrow. Maybe nothing at all. The things already discovered are extremely important for us to understand who we are. And this is very important. That makes the universe very interesting. Again, I do not exclude that maybe God will create other universes also interesting, but in different manner, who knows? But our universe, this is very important knowledge, not only for scientists who are crazy about this, for all humans. You know, I was in CERN when Higgs boson was discovered. People around just went there like in Mecca, like the paladins go in Mecca in these special days, of celebration of Islam. So it was crazy enthusiasm of people who have no idea what is Higgs boson, but they were crazy about this. Why? Because it was telling people that they have, again, one more confirmation, that they have cosmic scale of the universe.
Okay,
this scale of human
it's
beings, this
actually
revelation.
we have time. James, if you could comment last, and we are going to question.
Yeah, just a quick comment. So I guess that's one of my, the discovery of CERN and things that's really exciting. And it's one of the reasons I love science as well. I guess that my concern is that if God is equally consistent with a wide range of possible universes that would be interesting in their own right, then I just don't think it's a very good explanation for why we observe like what we do. And I'm not proffering necessarily a better one. I just think that we don't really have an answer to that at the moment. And that was sort of my main point.
Okay, thank you. So we're going to questions, and 2 minutes for response from speaker, and 1 minute for response to response. So this would be schedule. Okay, first questions for Alexey. Alexey, what kind of equation would you expect to see in uncreated universe?
In which universe? Sorry, Misha.
Uncreated universe.
Uncreated universe.
Yes.
Well, if it's not uncreated, so it appeared by itself, you mean? So the author would not expect anything specific. Have no idea if it is uncreated, what it is. I don't know. Nothing special. Maybe some sort of mathematical garbage. I don't know. Maybe. Most equations, by the way, are mathematical garbage. Elegant equations is a very tiny class of equations.
Maybe chaos. It could be chaos in universe or not.
But chaos, again, it's a word which requires a lot of discussion. Elegant equations may generate chaos also in solutions, but equations by itself are not chaotic. In uncreated universe, some equations could be chaotic. Some laws of nature, if there are any laws of nature, I would expect no laws of nature or extremely complicated laws of nature, non-elegant Some sort of mathematical garbage, as I'm saying.
Okay.
What else?
James, could you?
Well, I think that the issue is if we're trying to explain why we observe the laws of nature that we have and the constants, then what we should do is try to proffer theories that give an explanation or an account as to why this or this at least range of possibilities and not others that could have existed. And I mean, I take it that that's what an explanation is trying to do. And I just think that there just aren't plausible offers on the table at the moment. I mean, necessity is probably the best, and it's not even really an explanation. It's just saying this is the only way it could have been. So there aren't other possibilities. As I've said, I don't think God does that because it just doesn't seem to narrow it down for me. But again, I've made that point before.
Okay, let's talk about necessity for a couple of minutes. Alexey, why do you think that just brute facts, it's not explanation for Pythagorean universe?
Brute fact, the laws of nature, brute fact. Yes, I don't think that is an explanation because it is what is in philosophy called contingent thing. It could be otherwise. So we see something very special, and we see that the laws belong to very tiny group of mathematical structures. And then to postulate that it is final answer, that this belonging to very tiny and special group does not have an explanation, it means that no explanation, no mystery, because mystery is also not accepted in this way, that it is absurd. So it means that absurd is ultimate source of reasonable structures of the equation. But if the absurd is more fundamental than the beautiful mathematical reasonable structures, then the whole cognition is compromised. It is unreasonable. The reason itself would be compromised in this way. To accept the laws of nature as a brute fact, it's unacceptable, because it is the same as accept the primacy of absurd. Okay,
James.
Well, unsurprisingly, I don't agree with that. So, I mean, suppose you ask the question, why is the second decimal digit of pi 4? Well, I mean, there's no real answer to that question. It's just necessary. There couldn't be any other way, given the way pi is defined, right? That's not a brute fact. It's necessary in that it's true in all. It's the case in all possible worlds. That's the hypothesis that is on the table with respect to the laws of nature. Now, it should be pointed out that this isn't necessarily the laws of nature as we currently know. This might be a sort of a completed laws of physics, which might be even centuries down the road, in which we have some sort of, I don't know, string theory, or who knows what it would look like, right? So it might be a lot more developed than what we have at the moment. But the idea would be that there's however the universe is, it is that way necessarily. And so asking why it is that way is just to ask, why is the second digit of decimal digit of pi 4? Well, there's just no answer. That's just the way it has to be. It couldn't be otherwise. I don't think that that's absurd or undermines cognition or anything like that. That would just a hypothesis about the way reality is. I mean, I'm not saying that we know that it's necessary, to be clear. I'm just saying that I don't see a problem with putting that forward as a hypothesis.
Okay, and Alexey, could you comment? In your quote from Stephen Hawking, Hawking say something, could God create otherwise universe? And what do you think? Could God create otherwise universe with different laws of nature to human existence?
I don't know. Who knows? This is a question. Actually, Hawking quotes Einstein in this respect here. Einstein asked the question, did God have a possibility, an option to create the world otherwise? But Einstein, by the way, said this in the year 1925, according to his pupil, Esther Polyanskaya, her name actually, Russian girl who was a pupil of Einstein, and she wrote in her recollections. But in 1925, but actually the author of this question, I think, is Wittgenstein, who wrote this in his Tractatus in 1921. But this is historical point. Was it possible for God to create other universes where, again, thinking beings are able to discover those? Who knows? But my point was that our laws belong to a very tiny group, discoverable and anthropic altogether. And the conditions to be discoverable and to be anthropic, they are opposite. Anthropic requires the laws should be rather complicated to allow life and thinking beings. Discoverable requires for the laws to be rather simple. So the laws are simple and complicated altogether. So they are in the intersection of simplicity and complexity. They are very, very, very special. They're precisely chosen. They have all the features to be precisely chosen. Maybe there are some other laws in this tiny group. Who knows?
Okay.
Maybe not.
James, would you comment?
Well, we haven't talked too much in this debate about the idea that the sort of laws of nature and constants are fine-tuned for the existence of life, or anthropically permitting, as Alexey sort of put it. I mean, I'm very skeptical about that argument because I don't think that we know what the space of possibilities looks like and how many of constants of nature, let alone laws of nature, would be life permitting. And furthermore, I also don't know how what we know about the space of possible laws of nature in terms of their discoverability, nor do we know how discoverable the actual laws of nature are. As I've made the point before, we really have no idea, or let's say little idea, how much of the totality of sort of nature we have discovered. I mean, because we only know what we know, right? We don't know what we don't. Well, we know some of what we don't know, but we certainly don't know all of that. So I guess the point I'm making is Alexey's argument is that we live in this very special combination of anthropically allowing and also what's the other one? Discoverable laws of nature. And I'm not convinced that that space. Well, I'm not convinced that they necessarily are that discoverable. But even that aside, I'm not convinced that of the overall set of possible, sets of laws of nature, that the range of those that are anthropically allowing and discoverable is small. I think that we really have no idea what that, whether that's the case. Now I know Alexey doesn't agree with that, but that's obviously a point of difference.
Okay, thank you. So next question for you, James. Are you a real skeptic? Do you doubt that your opponents does actually exist? And if not, I know one real skeptic who probably would call you dogmatic.
So am I a real skeptic? Was that the question?
Yes.
A real, I don't know what a real skeptic is. I'm not a global skeptic, if that's what they mean. So I don't like deny the possibility of all knowledge. I would call myself a skeptic in the, I don't know, like in the Humean tradition, if you want to call it that, or like scientific skepticism. I'm happy with that as well. But that doesn't preclude the possibility of knowledge. It's just I'm skeptical about claims about very, maybe we'll say sort of grandiose metaphysical claims, such as that of all of the space of all possible laws of nature, we sort of have knowledge of which of those would be discoverable and which would allow life. Like I'm pretty skeptical about that, among other sorts of things. So skepticism has to be quantified in terms of the domain that it applies to. It's not like, well, if I'm a skeptic, that means that I just like, I'm skeptical about every single claim that anyone could make, including that my opponent exists or whatever example was given. So I don't quite understand the question.
Okay. I think the question will be about that we all accept some axioms to live, and you also accept axioms, and how you justify these axioms on skepticism.
Right. Well, that's a bit of a different question. That's really asking about my epistemology, which, to be honest, we haven't really talked about today. I mean, I don't think about epistemology that is like justifying knowledge in terms of a set of axioms that you derive things from. I think about things a bit differently to that. So I lean towards sort of a coherentist view, where it's a sort of the coherence relations between beliefs that have justificatory power. But that's a whole separate discussion that we can't really get into here. But even if I put that aside, I mean, if I have axioms or other basis of like foundation, other things that serve as a foundation of beliefs, then I can put those forward. We can critique them, give reasons for and against. I mean, that's going to be the same for Alexey. It's going to be the same for anyone, right? I guess I'm not seeing the force of the question.
Okay. Alexey?
Could you repeat the question, please, Misha?
The question was about the question was about skepticism, but we all accept some axioms to live in our universe, and if we are real skeptics, then why and how we justify our axioms?
Okay, so first of all, I'm not skeptic, and I distinguish skepticism from rational criticism. Skepticism, as far as, for instance, Bertrand Russell defines this term in his history of Western philosophy, skepticism denies any sort of reliable cognition outside common sense, outside common experience of every day. So roughly speaking, But scientific attitude is not skeptical attitude, it is critical rationalism. So critical rationalism implies two complementary points. One is criticism. So whatever axioms we have, whatever laws we already discovered, whatever we know, we should check it and recheck it again. This is criticism. But the second part of critical rationalism is, I would call it reliance. So at the best of our knowledge, we rely on our laws, which not yet refuted, and we make conclusion and live according to them. Of course, we're setting our at risk with this, because who knows, maybe we adopt some mistakes. Maybe the laws which we discovered, maybe do not work in that specific situation where we are going to use them. This is risk. So critical rationalism assumes certain risk, but this is the way how accumulation of knowledge agrees. So seeing the disagreement of our conclusions based on our theories with our experience, we have to correct our laws, our ideas about the universe, etc. So this is my position, and this is position of critical rationalism. It's not skepticism. Skepticism is dead end. It is intellectual cowardness, actually.
Alexey, it's time. Second question for you, Alexey. How many laws of nature would you expect to be discovered in non-created universe?
In non-created universe, maybe none, because it would be piece of garbage. None, no loss at all. I would not expect in non-created universe thinking beings to appear, by the way. I wouldn't expect life there. It will be just piece of garbage. Life is much more. So to have life, you already need actually creator. We did not discuss about this, but this for sure, because life is something very special. If non-created universe, it means that something take some arbitrary formula, they would generate nothing. It will be piece of garbage.
Okay, James? Well, my answer is not going to be that interesting, to be honest, but because I believe the universe is uncreated, I would say that we would expect an uncreated universe to look roughly like what we see. If indeed there are other possible universes. If the universe is necessary, then of course there are no other possibilities. But again, I would say that I just don't think we really have much knowledge about what the set of possible states looks like. So I think that any inferences on the basis of how wide or narrow the set of possibilities are with respect to, say, discoverability or life permittingness or anything else is largely speculation. I just don't think we know that.
Okay, next question for you, James. Those who know what elegance is, discover equations, and those who not operate with this criteria of elegance and discoverability actually not discover these laws of nature, etc. So this criteria is actually pragmatic. What do you say about this? This is very useful criteria.
Oh, well, yeah. So I mentioned that. I think my main problem with the notion of elegance is that it's just quite vague. It's certainly true that many scientists have been interested in sort of elegance and have talked about that. That to me, that doesn't actually. I mean, I don't think that's counter argument. It's just that they've used that concept and it's also vague. So part of elegance is, I think, simplicity, and there are arguments to be given about why simpler explanations that are explanatorily adequate are to be preferred. So I don't think that aspect is purely pragmatic. However, I don't also think that simplicity is the same thing as elegance. For a start, I mean, why have two words if they're exactly the same? And also, it seems we use them rather differently. So in so much, I guess I'd say it this way, in so much as elegance is not the same as simplicity, sort of Occam's razor kind of thing, then it seems to me that elegance is largely a pragmatic or aesthetic criteria or desiderator, and doesn't necessarily have any more importance than that.
Okay, James or Alexey?
So as I stressed, elegance was very, very pragmatic. So if the world is created by great superior mind, that this mind, it was expected, this is Pythagorean phase, then it was expected that the laws are mathematically beautiful because he creates everything beautiful. Life is beautiful. You look at the sky, look at the birds, and if you have an idea that the mathematics is at the core of material world, the mathematical laws must be beautiful. And this narrows a lot, actually, narrows a lot the search. And that is why Newton wrote 1 hour R square. That's how Maxwell actually discovered his radio waves and classical electrodynamics. That's how Einstein discovered general relativity. Dirac discovered antimatter, etc. So this is very practical thing, elegance. This narrows search extremely. And the mystery of our world is that prejudices of human beings based on their ideas of beauty and elegance are very much compatible how the universe is constructed. So we are, our reason, our little say reason, and the reason embedded in the universe are compatible with each other. We are able to see the big reason with our small reason. This is the point. And we are led by the idea of beauty. So in this point of view, the elegance and beauty and aesthetics is more fundamental than physics.
Okay, thank you. Let's talk about some objections of James. Alexey, why do you think that some non-rational force or non-rational law can't create this universe with this type of laws of nature?
Non-rational force. I don't know what it is, non-rational force.
For example, like in Hinduism and Buddhism, and etc.
Well, this would bring us in hard problems of discussing of these Indian ideas. What I would like to avoid it, because I don't think that I myself don't consider as an expert on this. My knowledge is very limited. So what I am talking, my point is that the Pythagorean argument tells that our world was created by superior mind. And this is very clear. So mind is general idea for all big philosophies. Also in India, it is one of the big ideas. And God is associated with mind. Atman is Brahman, you know, this one of the famous formulas. Association of human mind with divine mind was the leading idea also in Egypt, in India, in Middle East, etc. It is that humans are children of God is actually a very general idea. It's not only biblical idea. It's much more. And this idea was very important for discoverability of the laws of nature. That's what I could say.
Okay, thank you. James?
Yeah, so I disagree. I've mentioned before my disagreement about the importance of the idea of divine creation and the idea of us being children of God with respect to how important that was about the early development of scientific theory. So I've already mentioned that. The other thing I think is that although the belief in some sort of created God of some kind is not universal, but it's found in many different cultures, the particular understandings of the nature of that God are often very different. And so the reason I think that's relevant is, as Alexey pointed out before, it's not just like using the label God or saying it's a creator that's important. It's also the particular properties of that God that are needed to do explanatory work. So I think that the specifics kind of matter a lot there. And one of the reasons that I mentioned alternative conceptions, such as in some Eastern religions, Hinduism has a concept of God that's different to the Western concept, and then in Chinese tradition, it's even more complicated than that. Let's say, is that those are? I mean, if we're going to say that natural or material causes are off the table or insufficient, then I think that we need to consider a range of possibilities, and that's something that I also take sort of seriously. Is if I'm wrong about the materials causes as well, we've got to consider what other options are on the table, and see what things are actually needed to do the explanatory work. So I think that it's important to think about it that way as well.
Okay, thank you. James, question for you. Do you think that multiverse can solve problem of laws of nature and etc.?
Well, hypothetically, yes. I'm not really a fan of multiverse theories. Again, I do think that they're a possible explanation, so they need to be on the table. That's as I mentioned about the alternative non-natural conceptions. I think one of the problems with multiverse is that it often gets what from my point of view is sidetracked into discussions about specific hypotheses of the multiverse. Alexey, in his, or at least one of the articles that I looked at, talks about Max Tegmark's idea of a multiverse, which is more of a mathematical multiverse in terms of all mathematical structures existing. There are other hypotheses that are more grounded in like string theory or other physical theories, which are a bit different. Those are interesting, but I guess the point is, what we have to think about is what is necessary for explaining the alleged phenomena, the simplicity, elegance, and understand or discoverability of the laws of physics. So what we would need is some sort of large ensemble of possibilities of universes that have, say, different laws and different constants, and then some argument as to why we find ourselves in a universe that has the properties of interest. Now, that maybe is an anthropic argument, saying something like, well, obviously we can't find ourselves in a universe that doesn't support our existence, so we find ourselves in the one that does, although you still got the discoverability thing to address there. Another possibility is to make some sort of selection argument, so analogous to Darwin's theory of evolution by natural selection. So some process for saying, look, universes that have certain properties become more common over time because of some selection principle, unclear what that might be exactly. So to answer the question, do I think multiverses can explain it? In principle, yes. What I think we should focus on is less about, say, the physical justification for these theories or even mathematical or whatever else, and just look at what would be needed to explain the phenomena, and then what hypotheses are on the table for sort of doing that. And so I think that minimally, you could just say, look, there's a process that generates different universes that have different constants and laws of nature, and some unknown selection principle that prefers universes, prefers in a not in terms of a mind, it just that selectively generates universes that are more discoverable and have more elegant laws. And in one of the debates with I've forgotten his name, a philosopher that I was discussing with, has talked about this as a stalking horse principle. It's a minority, I can't recall his name, but just the idea that we may not know what it is, but there could be we can invoke such a principle that selects particular types of universes, and then that will give us an explanation as to why we find ourselves in one that has sort of elegant discoverable laws. So I think in principle that's just as plausible as the God hypothesis, because, well, we can't really say why God made the universe just the way it is, and likewise we can't really say what the nature of the selective principle is. So I think that they're both sort of equally bad in that sense. So yeah, maybe it can, but there's a long way to go.
Okay, thank you. Alexey?
Alexander Malpass, sorry, that's the philosopher I was thinking of, Alexander Malpass.
Okay.
So when people are talking about multiverse, there are many ideas incompatible between each other about multiverse. I myself could suggest a multiverse. By the way, we already discussed it a little bit with James. That the question, is it possible that God created other universes, not only our? I think that most likely yes, because God is creator and like a great artist. It would be strange to expect that a great artist painted just one painting. From great artists, you expect he painted a lot of paintings, or made a lot of sculptures, or made a lot of movies. From this point of view, I expect from God to create many universes. So I myself inclined to believe in the multiverse, but this not the multiverse which Max Tegmark suggested, or multiverse which can be sort of big pile of garbage, mathematical garbage or whatever. God created beautiful, interesting, wonderful universes, meaningful, very meaningful universes. In this multiverse, I can believe, yes, why not? I seriously, I think that it is most likely it is like this. But I do not believe in the multiverses which are generated by some meaningless and useless and pointless process, where there is no beauty, meaning, good, etc. In this multiverse, I don't believe. Not just I don't like this idea, but this sort of ideas, they contradict to discoverability, to life, to very special character of our laws. Our universe cannot be a member of this set of garbage universes. It's impossible.
Okay, thank you.
Logically impossible.
So we all have time. Let's make a conclusion. 2 minutes for each speaker. Alexey, would you first?
First of all, I'm thankful to you, Misha, and to James for this discussion, because I'm looking always to people who would like to object my Pythagorean argumentation, and I appreciate that James took this challenge and suggest his best refutation. So this is important for me. I will think about this. So thank you, James, for your willingness to discuss, and you did your best, I think. Thanks for that. And I hope it was interesting for people who are watching.
Okay, thank you. James?
Yeah, likewise. So thanks, Alexey, for the discussion, and Mikhail for organizing this and doing a great job with moderating, keeping us to time as well. It's appreciated. Yeah, I think that these are important questions about the relationship between sort of, mathematics, the human mind, laws of physics and laws of nature, and well, the existence or non-existence of God. I guess at the end of the day, I'm not convinced that God provides the explanatory value in that Alexey thinks it does in this sphere and in others as well. But yeah, I mean, I think that the only way we advance this discussion is to basically, put our arguments forward and see how the cases stack up. So yeah, I think that yeah, happy for this opportunity. So thanks a lot for the invitation.
Okay, thank you. And last words, where people find your work, Alexey and James?
My work can be found in my website in English, in Pythagorean Universe.com. There are 2 articles in English. Mostly I'm writing in Russian, but these 2 can be found in English. And also, if somebody will look for International Society of Neoplatonic Studies 17th conference, we presented there another paper which was published there. So that's essentially all. Not many articles I have in English, but in Russian I have a lot. Go to snob.ru and you will find a lot of my Russian articles and essays on different philosophical matters.
Okay, thank you. And James?
Yeah, so there's a few places if you're interested in sort of my stuff. So you can check out my YouTube channel, just James Fodor, and I do some more videos talking about this sort of stuff, and on other channels as well. You'll be able to find that just by Googling that. I have a podcast that I mentioned where I talk about science topics. So the Science of Everything podcast, or just Google my name, you should find it. I have a blog as well that's called The Godless Theist. Again, Google my name is probably the easiest way to find it. And finally, there's my book, which I did mention before, but I'll mention again, Unreasonable Faith, about critiquing William Lane Craig's arguments for his brand of Christianity. So you can get physical or digital copies of that on Amazon or elsewhere if you're interested. So yeah, that's me if you want to see more.
Okay. Okay, thanks everyone. Thanks Alexey, thanks James, and thanks our listeners. This was a great debate, and I hope you will see this debate in future in Russian. So thank you, and see you next time.
Thanks.
Thanks to everybody who listened to us.